For the break, looked at policies and stuff, and this is an active subject we learn by doing. And we'll have a lot of following along examples in classes. Very stripped down, minimal clutter, like print words that say these are words to be printed, that sort of thing. Try to get all the clutter out of the way just to see that bare minimum part of class examples. But we'll do our first example. So we'll make sure you have Java installed. And there's a couple things when we say install Java, a couple things are going to pull up. Java for Windows is probably, oh, it says it right here, Java runtime environment. So one of the big things about Java is the early 1990s, if we're going through the history of Java here, the early 1990s, there was, they were making a universal remote. Those become standard, right? Everybody, I assume everybody's used to universal remote. You lose your TV remote or the batteries go dead, probably another remote in your house you can grab and reprogram to your TV. But it was one of the early experiments in that. And at that point, long before the days of Google, so we couldn't just Google questions, C++ had really taken off, and it was an unruly monster. Everybody just did their own thing, and it was a mess. It was a complete and utter mess, so they were like, okay, we need to clean some things up. So they sat down and thought of some ideas like, okay, let's set up some naming conventions. Let's not allow any overloading operators. So the plus sign is overloading. We can concatenate with the plus sign, or we can do addition with the plus sign. And that's pretty much the only symbol that has more than one meaning. Right? We can't suddenly decide that a curly brace is going to be used for addition. And then we're also going to use curly brace for modulus, and the computer will need to figure out which one's which. That's called assigning more than one function to that symbol. That's called overloading. And in C++, we can do that character by character. So that's one of the things I got rid of, because that leads to, obviously, every programmer has different ideas of what a particular symbol should do for most of them. So that leads to quite a mess. They switched it so we only overload methods. We will see that next week. That's on next week's to-do list. But we will write methods with the same name, but different parameters. So like an add method, and one of them takes two integers and adds those together. And another one takes two floating point numbers and adds those. And another one takes a floating point number and an integer. So we have three different versions of that, and they all have the same name. And they came up with some naming conventions. I won't talk about them when we got to them, but basically variables and methods are in camel case. Everybody familiar with camel case? So first letter lowercase, fully spell out all of the words, and then just jam it together for variables and methods. Class names. So everybody saw object-oriented programming, the prerequisite, right? So Java is object-oriented only. I have that. Class names are in Pascal case, and constants are in all caps. And this is part of the unwritten agreement. We will get to this soon. It's called beans. We'll talk about it in detail, where we just kind of all agree to write it the same way. It's not going to cause a compilation error if you write your variable names in snake case. But what it would do is other programmers would look at you funny and be like, I thought you said you knew how to program Java. That's not the unwritten agreement on how we all write our code the same way. So when we install it, they started cleaning C++ up for this one project and came across something good. So they just kept going. And eventually, very shortly, it became its own language. And C++ has grown into an unwieldy monster. And this was before the days of Google. So that meant paper documentation on what all the programmers around the world had done, if they made documentation at all. It was just an unwieldy monster. So when they cleaned up and organized it, a little subset of it, it took off really, really well. Lots and lots and lots and lots of people around the world like that idea. Like, yeah, it's like grammatical rules for programming. We all write code the same way. It makes it easier to do a lot of things. We can, uh, our, our programs can all interact better. We can download somebody else's library and use it, happily knowing what they did. Because we just like grammatical rules. And eventually it became its own language. So when we install it, you actually need to install the JRE is Java Runtime Environment, but what we want is the JDK, that's Java Development Kit. You'll see that a lot in software development. There's SDKs, or sometimes like Java will change the first letter. So Java Development Kit, which there's a link right in there. I installed 20, which runs really, really well. I'd say anything later than 17 is good. So I installed JDK 20. Just search for install JDK. The link to this page right here is on your thing, so they recommend 17 and 20. Obviously, 18 and 19 came out in between. The changes in 18 and 19 are high level stuff that unless you are changing how your operating system handles its RAM chip, you probably don't need any of the specialties from 18 or 19. 17, 20, and 21 is going to have a whole lot of things that are easier for beginners. We will see that when it comes out here in a couple of weeks. I'm anxious for it. A lot of the boilerplate code, the stuff that's always the same, and just has to be typed there, the compiler is going to start typing that in Java 21, which comes out next month. I will 20. 17 is really good as well. One of those, just use the system and run the installer for it. Really straightforward. And if you haven't done so yet, you might want to do that before installing NetBeans. When you install NetBeans, that's going to bring in an installation of Java, which I think the latest version of NetBeans brings in Java 17. So you wouldn't, either of those, JDK 20 or whatever. But as long as you have Java installed somewhere, we need to open a terminal and make sure that installed. I'm just going to open PowerShell. If you type Java, you should see like the help menu pop up. That's all. There's some standards. I think the standard would be like -V or something to get the version. If you get an error message that something went wrong or the environment variables don't know about that. What all systems are people on? You're a Mac user. Give that a second. Y'all are in Windows machines. Windows machines on Zoom call. So if it doesn't recognize Java, you might need to add it to the environment variables. So in Mac, it's easy. Mac. I think you've probably seen it before, but still go through. Oh, how the environment variables, so path, which actually I can say in Mac, export path, and then the directory where Java was installed. Does that sound familiar? So on Windows machine, there's a few extra steps. So if you search for advanced system settings, there's lots of ways to go in here. Actually, what I do most often is hit Windows X and then Y for system. And on the system about, scroll on the advanced system settings. You can search for it in the search bar or whatever. But in this little box that pops up, down under the advanced tab at the bottom is environment variables. And there's two boxes, the one for the user that's logged in or the one for anybody in the system. I usually go to the one in the system. Both of them have this variable called path. And if you're on Linux or a Mac, you also have a path variable, which there's different ways to say it. This is basically the programming languages that your operating system knows about, which is just a big list of things. So just make sure that the file path to where Java is installed is on there. For Mac users, I can do it at a Z shell, bring it here. Yeah. So, and make sure it's just points to where Java is installed, which should have happened when you ran that installer. But if it didn't, or just in general for software development, that's the list of all the programming languages your operating system knows about. Or other things, or go back in there real quick, like, what else? I just did a factory reset. Supply. So the text editor I use, I want to be able to open that from a terminal. So it's out of the directory to where that's located to that variable, and that's what basically. Then okay, I think, and when you put the word job, you should see something other than an error message. That real.
Yeah, I'm here.
Okay. So, you said that. I didn't know if you had a question. Okay. For Mac users, so Joseph here, I'll do it in Linux. It's the same thing. So you have a path variable. Clear. So you could like echo $path in all uppercase letters, and you'll see all of them. If it's not on there, what you do is you export path equals $path for everything that's already in that variable, plus, and then in quote marks the directory where it is. But when you run the installer, it should have put it on that, should have put it on the path variable. Mac definitely knows. Mac knows what Java is. But just in case, or just general software development, it's called path on all of our operating systems. I just did the Mac example from a Linux one. But that's how we tell the computer where our operating system is. So navigate over the working directory, documents, /delete. Okay, good. Nice empty folders, so we can start doing stuff. I use the Sublime text editor. But whatever text editor we normally use, I think most people use VS Code these days, right? Just guessing. And I'm going to create one. The name matters. So I'm going to call it hello. In Pascal case, remember I said class names have to follow, or in Pascal case, .java. So that's going to be the name of our text file. And the class we put in this file has to match the file name. So the file names will write that in Pascal case. I'm just going to call it hello for greeting and create that with the text editor. So a couple quotes. So some keywords. First one is public. Public means accessible from other software, eventually leading to the user, but the user only interacts with it through other software. We interact with the operating system. The operating system eventually only interacts with the Java virtual machine. That's how they originally got the original cross-platform going. They wanted to write once, run anywhere. It's not as big a deal in 2023 as it was in 1990, early 1990s. So write once, run anywhere, and they did it by creating a small, lightweight virtual machine. Which, when we get to Docker and containerizing things, that's kind of become a standard for all of our stuff. But we'll work with that soon. But public means other software can access it. Then class, every one of our Java programs is going to start like this. Everything is object oriented. Remember, a class is a design or a blueprint for what we want. Blueprint's a good example, like subdivisions in America. So 10 acres of 2-bedroom ranch homes with a garage and a basement. They're all made from the same blueprint, but they're all a little bit unique as well. So class is the design, the blueprint for it, and then we will instantiate that class into objects, those little unique versions of that design. And then a name, so we'll call it hello, and then some kernel braces to indicate where that's going to be. So, well, there's more stuff coming to that soon, but every one of your Java programs has to start out like that. You have to create an object. Then we need a starting point. This is one that is way in the background in Python and we can't really access. When I stopped saying that, some of y'all may have heard me say it in covering a Python in an earlier class, that there's those things that we have access to, and there's one that we say the new one we technically have access to it, but don't ever touch it. That's our starting point. So we don't know how to do a starting point here. Here we have to actually create a starting point. So one of the keywords we've already seen, it needs to be accessible. Our operating system has to access it. So it has to be public. It's object-oriented stuff. So we need to create an instance of an object, and then we can ask for all the variables and methods in that object. But there's a problem. This is step number one. So how can we access that stuff if we don't have any objects created yet? That's where static comes in. Whoop. Let me put my filter in another place. That's where static comes in. Static means there's one and only one copy. If there's more than one copy, the computer will delete one of them. And if there's only one copy, then that means we can use the copy in the blueprint, not on any particular instance. So one of our instance places for static is what the very first steps. Things that run before the program starts, because before the program starts, accessing the database, there's some stuff we want to do before the program starts running. But we don't have any objects to do anything before the program starts running. So we use static for one and only one copy, because if there's only one copy, then that means we can use the one in the blueprint. If we're using the one in the blueprint, there's some other things. So like everything made from that blueprint can share the static variables. So we could set up counters. We have objects for veterinary clinic. We have animal objects. We can put a counter in there, a static counter, and then no matter how many objects we make from that class, they all share that same counter because it's static. It's back in the original design. Those are the main two places where we static, but our starting point has to be static because there's nothing there to pull from. Then it's strictly typed language. This is the one that's going to take the most getting used to. If you've done a lot of Python and got used to dynamically type, where we just say we have a variable and then we can do whatever we want with that variable. We can put an integer in there. A few minutes later, we can switch that out with a string, and later on, we can put a boolean in there. Dynamically typed. But Java is strictly typed. We always have to say what type of data we have, which that's the main factor making Python slow. So it's much faster. The computer never has to waste time figuring out how much RAM to use. If we say we have a floating point, a float, that's one of our types, takes 32 bits. The computer sets aside 32 bits in RAM, and that never changes. So the computer never has to waste any time. It's considerably faster. So we always have to worry about our data type, and our methods have to return something. Void is not return, which is actually something. We probably won't see it in this class. For sure, we won't see it in this class. Those who take the SDEV 264 class, you will see it there. But void is an object. Everything's object oriented, so there is an object that represents nothing. There's two objects that represent nothing. There's void and null. There's two types of nothing, but our main method, this is the starting point. There's nothing before it, so there's nothing we can send back afterwards. And then we need a name for it. The Java virtual machine is expecting something called main, and then some parentheses. That syntax. So y'all have seen the method name with parentheses, I assume you know. And it takes in parameters, because here in a moment we're going to start this from a terminal. So we can add more strings to send in there. So we need a place to put those strings if we want to send extra ones in. So we'll create an array of strings. That's going to be the biggest difference from Python. Python doesn't have arrays. We sometimes use the word. This is a real array. When we set it up, it is following a very precise algorithm of where we store it in RAM. It is way faster. but we can't change it. It's non-dynamic. We say we'll get to erase it, but they're actual real arrays, not just using the word array to talk about a list. And then we need a name. The traditional name for it is args. Args is the variable name. You can call that whatever you want. You can call it X. You can change that part. Everything else in that line is going to look exactly like that every time. Public static void main string, array of strings. And args is what they called it in the early 1990s. That's SQL solve. And then we need some curly braces. We'll talk stuff in here, but see how the curly braces don't have anything around them to tell what they are? The opening curly braces do, right? It's right by the main method. We can put those wherever we want. We can put it on the next line. I will do it this way. This is based solely off a survey. Somebody took the time to ask 10,000 programmers what's the easiest way to orient your curly braces and semicolon. And the majority said put the opening curly brace on the same line as the header, indent everything inside of it, and then unindent for the closing curly brace. So that is based purely on the majority. We could write this all in one line if we wanted to. It's really, really hard to do. Even for a simple example like this, it would be quite a bit to write that in one line. It's a really good idea. Come down and label these. So like in May. That way, step in between there, we don't get lost in those curly braces. We have a bunch of things going on. Get down to 10 closing curly braces and we start editing stuff. We forget to delete one, an extra. Anybody heading to IUS or to a 4-year school afterwards, I know goes to IUS. Or IUS, at least 2 of the instructors will require you to label every single closing curly brace. And it's a really good idea. Just have a comment in there with 2 slashes for a comment. And that way you can tell what each curly brace goes with. A useful thing, not a requirement. I'll probably mostly just label the important ones to get to those. And then inside the main, we need to do some stuff. So our basics are going to be the print stuff. And I'm going to do a basic print, but system. I'm going to do a basic print line, but we have a lot of options. I'm going to point at this. I look for buffered output stream. Notice there's this official one here from Oracle. Says Java Platform SE8, says which version it's on, all that. Here's the official documentation. Now with that different one here, we have lots and lots of options. Y'all all know the word streaming, right? That comes from Java. We don't know. We have control over how we do it. So like we can have a buffered stream. So we set up a buffer. We say we want to send it to the console 4 bits at a time, or we want to send it to the console 37 bits at a time, or whatever number, however many bits or bytes we want to send at a time. We have control over that. Lots of different ones. Become a filter output stream. Buffered output stream, checked output stream, so we could validate our data as it prints out to the console. We could cipher, so we could decrypt and encrypt it. We could or encrypt and decrypt, whichever way we want to go. Set up some sort of cipher. We could set it up as data. Deflators and inflators. We'll talk about what those are later. And, we don't need to waste RAM doing something the CPU can easily calculate. So we deflate it and store it in less RAM, and then the CPU calculates it when we throw it back on the screen. We have more than just print. We're just going to use the basic print stream for example. But you see lots of different options on how we print to the screen. We'll see a lot of those. And look at those naming conventions. See the naming conventions? They're all objects in Pascal case, buffered output stream in Pascal case, checked output stream, cipher output stream. And this website here is the official documentation. And this is generated from JavaDoc was one of the, I don't know if it was the first one, but it was the first one, the first really big language to do website generators in our comments. So we will definitely cover JavaDoc soon. And We just had some special comments in, and when all of our IDEs know what it is, and it'll throw in the correct style sheet and everything for that, and it has basically everything in the Java language. This is where you want to, those who haven't even class before, I know you've heard me say it. Always look at official documentation first. It's not going to make a lick of sense, probably, right? When we go up to that page, I was just on Control H. Always look at the official one, so always look at the official documentation first. Annotated material. So during reflections, we're creating new annotations, we're going to do this. That doesn't make a lick of sense, right? It's going to be super confusing first time you look at it. But this is the official user manual for Java. So always look here first, and then go check the tutorials, right? But I just look at reflect. Reflect in Java. Oops. And maybe find some YouTube videos. What is Java reflection? What is it? Why does it matter? That probably explains it really nice in 3 minutes. Then check the tutorials like you would normally use, but instead of learning that one function from the tutorial, use that tutorial to learn to read the user manual. Then come back over here, and then hopefully that sentence would make a little more sense, because tutorials only have the introductory steps. Tutorials are out of date. So use the tutorial to learn to read the user manual. Just take a little bit longer at first, but then you'll know how to basically make sense of the user manual for Java, which will go a lot further. Check documentation first. It's not going to make a lick of sense, especially at the beginning. Then go look at the tutorial and use that to make sense of the documentation so you can see the whole picture, not just that one step the tutorial's over. So to print this out to the console, there's layers of control. This is a great example of that. So we need to access the operating system. So operating system has access to the screen, the monitor. So system and object-oriented, same object-oriented notation we use in Python, the dot notation. I believe everybody's seen Python before. So system dot out, and then we have a bunch of options. We can go with print ln. That's print line. So print with a line feed at the end. And then we can add in a string here. Hello world. There's our basic hello world. All this setup looks like a lot, right? This is that thing I was talking about earlier. We have to do all those other lines for that one line of code that we wrote. It seems like a lot of setup, but when we go to write 1,000 lines of code, it's that exact same setup. So it seems very, very small there. Java is for big things. So that's why we're going to do that. And every one of those words means something. Now we have to compile this. So I'm going to go over to terminal. Actually, I'm going to use that. I'm going to come over to the regular terminal instead of using the embedded one. And to compile it, Java C is our compiler. So we list out the things there. So we have this hello.java file. So Java C is our compiler. So we want to compile hello.java. And this is the no news is good news situation. If something's wrong, you get an error message. Let me go take the R out of print so I remember what I did when I get back over here. If I try to compile that now, get an error message. So I go, there's something not recognized in there. Usually the compiler gives a little pointer. It's like, got up to here. You see the caret there. I'll say I ran up to there. So it's one of those situations. We know for certain that the error did not happen after that spot. So we look there and then work backwards till we find it. I made that on purpose, but the compiler will either throw out an error message or nothing. So if you don't see any result from that, then it should have created the second file, hello.class. That's that's bytecode. Let's look at bytecode. And Sublime will recognize bytecode code. So let me go over to just super basic Notepad and open that. Open. Files. So the text editor can't quite figure out what to do on some of it. Some of it's just binary. Sublime will recognize bytecode and put it all out as hexadecimal. So I think the S code will do the same thing. But Notepad, it tried to do something, but there are some words we can recognize. Java language object. Talk about this soon. Object is like, if we use parent-child terminology for inheritance and objects, because everybody's seen that before. Object is like the grandparent. Everything comes down from object. If we don't, it is implied that we inherit stuff from object, which has equals, toString, hash code. We'll talk about what's in there soon. Looks like some sort of initialization. Oh, a few words. We didn't type java.io.printstream. So it recognized things that aren't even, it found text that is not even in our text file. There's the string we wrote. Oh, print line. Oh, that print string, whatever it asked for up there. Currently system.out.println is or system.out is replaced by java/io/print string. And it's not quite assembly language, but the Java virtual machine will recognize this. So the bytecode will look the same on any machine. Line number table, we're going to look at that in just a moment. Then notice that the name of our file is way at the bottom, not at the top where humans think of it as. Computers do stuff in different orders. What's in the text file is, this is what runs through the CPU. Or actually, this tells the CPU, excuse me, no, I didn't. This tells the CPU how to create the instructions that we want it to run. So what is in our text file is very different than what actually runs through the CPU. Remember that. Sometimes things that look like an utter mess in the text file will be super clean on when you actually see what runs through the CPU. Let's run this real quick. So we compiled it. Java C, compiled with no errors. We have this hello.class. And once we have that, then we have Java, which starts the Java virtual machine, and then the name of that class we created. And we do not need the extension here. So the compiler needs the extension, but the Java virtual machine does not need the .class extension. And that'll print out that words, hello world. No surprises there. So that's our basic printout. We're going to do some more stuff to that. First, we're going to run it a different way. We'll talk about what I'm doing here soon. But let me disassemble that. So here's what actually runs through the CPU. Okay, y'all saw that example, saw what that looks like. So here's what goes through the CPU. We set up a pool in RAM. Some built-in stuff. There's this long list here. So here's the things we have in RAM. We put 28 things into RAM for that code. And here's where we start doing stuff. So we load something into the A register, invoke special methods. So this is where we load our main method, our main static method into the A register. It's static, so it's going to stay there permanently. It's not going to be, it's going to be left there. And then return, and notice that return. Wait. I'll come back to that one. And then we come down here and do the inside stuff. Get static. So we're getting a static print string. Load LDC is load into the C register. Load into the C register number 13. Oh, I skipped number 7. So notice number 7. We come up here, and 7 is a reference to a print string. So we load a print string object into register C. Then we're gonna invoke some method, line 15. So come back up, check number 15, method reference to that print line method. After we do that, we return, oh, whoops, I skipped all the order. Get static number 7 is the print stream object. Load into register C the string hello world. That should be what's on 13 here. On 13, the 13th thing we put in there was a string, which apparently was too large for the 64-bit registers on my computer. It's Unicode, 16 bits a piece, so we need more than one register. So 13 trails over into 14, so it loaded that in. Mostly compressed it a little bit because that. Oh, no, that 128 bytes, that bits. Loaded that string into the RAM. Then it prints it out, then returns void. And then we come down and line 5 is 0. So we look back at line 5. Line 5 is where we ask for that print line method. So we replace the thing in RAM with 0. We wipe it out of RAM. Line 7 so where it says line 5, that's up to line 5 is replaced with what's in line, replaced with 0. So we wipe all that stuff out of RAM. Then line 7, we do what was in line 8, which is, or we put an 8 there. I'm not sure why we put an 8 there, not a 0, but we always do that when we return stuff. When garbage collection cleans it out, it puts a 0 in everything except for a return statement. It puts the binary representation of 8 in there. So it doesn't completely wipe it, but it always does it. And I didn't build the actual assembly language for Java, so I don't know why they put an 8 there, but that's what actually runs in the thing. That looks very, very different than our code, right? That's what's actually running through the CPU. The bytecode is the instructions on how to set that up. We'll talk about disassembler later. Anybody having computer science afterwards? Computer science worries about optimizations, right? Software developers worry about the code running. Like whatever, as long as the code runs, works as works. And the computer science worries about optimizations. The computer scientists would worry about this stuff a lot more. I mostly wanted to do a quick one, and we printed hello world on the screen. You see how long confusing this looks. That's why I wanted to look at it now. We'll look back at it probably with division. Y'all may have seen that before. Division takes a lot from computers, but we write our Java code, and then we come over and run our compiler. So Java C, the name of the Java class, and compile that. No news is good news. So then we can have the Java virtual machine run that class that was compiled from it. We don't need the extension anymore. So that's the steps to get the code to run. You might want to practice that with a few small things that all fit in one file, because before long we'll have a whole bunch of files, and that's where our IDEs are kind of coming in especially helpful. And so NetBeans here. Yeah, I'm going to go ahead and jump over to NetBeans. We could do some more stuff in this. I think in my notes I put do some more stuff on that. But we use a big powerful IDE because there's going to be lots of files there, right? I just immediately pulled up the disassembler, and all of that stuff, the entire disassembly was in human readable form, right? It told us what the 28 things we put in RAM are. And then it told us where to use each one. So we have access to control that. So real programming languages now. If all you've seen is Python or little scripting languages before, we don't just have the program thing. We tell the computer how to run. Not just run this instructions like this is use these bits and RAM, do this and that, and we have complete control over it. Which hopefully sounds good to most of y'all, because personality trait shared by programmers is we learn this because we're people that like control. I always like to point that out explicitly. Just keep in mind that when you're on a team of programmers, everybody on that team is a programmer because they have that personality trait of liking control. So when you're at a meeting debating things, it's a debate between people that like control. That when everybody in the debate wants to be in control. That personality trait is common among programmers, so be aware of it. And that helps being aware of that simple fact about human nature, the personality traits that led to us choosing to be programmers also led to other people choosing making the same choice. So we're all, when we start debating things, it can help keep tensions at bay. So I'm going to open NetBeans here. IDEs do a lot more. We're going to want organization on how that thing I just mentioned, how the program runs. That's part of our build. We build our code to run on a specific machine. It's always the Java virtual machine, but we have a little bit more control over that per se. But we build it to run on a certain machine, and we use the word packaging. So we need some sort of package manager to keep all these files and folders straight. And there's a couple options. So in NetBeans, there's new file, but we're going to have lots of files in any of our projects. So the next button over is new project, and the one after that is open project. So you need to open one, but click on new project, and then we have a couple options. So for class, I'm going to be using ANT most often in class examples. This was made by the developers of Java. This was one of the first package managers, one of the first build managers. Those terms are used interchangeably. That kept track of all that, how our files are organized into folders, where the manifest goes. Manifest is like the traditional usage with a boat. Tells the captain everything that's on their boat and why it's on their boat. And the captain is within the rights to throw anything that's not on the manifest off the boat. Same thing with the software program. If there's something in RAM that is not on the program project manifest, the CPU is within their rights to delete that from RAM. So things to keep all that straight. ANT was the first one. It came from a time when people were thinking of the acronym they wanted and then coming up with words. So ANT stood for another neat tool. There was a little thing there where people thought of the acronym they wanted first and then came up with a name for that acronym. But it was from that time when they organized it the way they did their files. They were the guys that created Java, so they definitely knew what they were doing. Really good organization. But it's human organization. It was not optimal for the machine. So a couple years later, the same guys made 5 years later some lessons learned and stuff. And what they did, this has computer optimization. Y'all may have seen some things like this before where there'll be like 15 folders deep, and each folder only has one more folder in it. And then we get all the way in, there's one file. And then somewhere else, there's like 15 other folders deep, and there's one file in there. That's better for the machine. I'll probably be using ANT for class because it's a lot easier to dig through the folders, and we're definitely going to dig through the folders. We'll be using Maven more often, and Gradle is just within a year of Maven being created, Gradle came out. They're counterparts to each other. So everything is centralized in Maven. There's one central Maven repository that Apache runs all of our dependencies. Anything we want to import is kept on this one single Maven repository. So we import everything from there. Our manifest, our build instructions, all of that go into one file. So everything's about centralization there. Gradle is the opposite. It's spread out. It's distributed. So there are thousands of repositories where we can choose to import stuff from. And our build instructions are spread out amongst lots of files. So I'll use the example. It obviously is different project to project, but a good example for that is Maven would have one file with 1,000 lines in it, and Gradle would have 1,000 files with one line each. Obviously, one of those is going to be much, much better for disk, hard disk, spinning disk, because then we only need to move that read head once, and then it reads from that file. Maybe, and the other one, Gradle, is better for SSD, because then we're just randomly pulling all those little bits, little things from different places. So something that you would actually put thought into which one you choose between those two. In class, I'm going to use AMP most often because we'll be digging through the folders and it takes forever to get all the way down to the actual file in both Maven and Gradle. They're pretty deep. It has to do with hash tables, which we will be making hash tables in a couple weeks. Java is for big projects, but depending on what you're going to do. I just think Gradle is better for SSD drives. Maven's better for disk drives. Most servers still have disk drives. So phones, guarantee your phone has SSD. Most laptops, about 50-50 on desktop, if they're moving that way, have SSD. So if you're making it for an individual machine, phone, tablet, laptop, desktop, you probably want to go with Gradle because it's going to have an SSD drive here. Java is used for big things, big applications, enterprise scale. Like you may have, probably 500,000 employees,
give or take.
200 million customers, big scale. That's what Java is used for. And big scale relates directly to big money. So it pays a lot more, but it's also going to be running on servers. So Maven's probably more common for your Java application because it's going to be enterprise scale running at servers where like Humana, where there's 500,000 employees all trying to access that same software all day long. SSD drives aren't going to keep up with that. They're quicker, but the drawbacks for SSD is there's a finite number of writes, whereas the spinning disk will last longer. Yeah, and they're in a server. The problem with the disk is the main problem is the noise, right? So if it's in a server room somewhere else in the world, then the noise doesn't bother us at all. We're just getting the results of it. But most of it Java would probably be done with Maven these days because of that distributed stuff. But that's how you would choose between the two of them. I'm going to go with Ant so that our Java files are only one folder deep and they're all in that same one folder. Human organization instead of computer. It hashes better. It turns to a hash table better. And when we can optimize turning things into a hash table, we get almost electrical speeds. Which is, yeah, the numbers you hear about your computer are still nothing compared to the speed electricity moves. So the closer we can get to that, the better it is. That's why Maven and Gradle have all those folders. It gives us better hashes, but we'll talk about what those are. So I just did a factory reset, so I haven't done anything yet on here. So I'm going to create a new Java with the Ant project. Java Web we'll do shortly, and Java application. First off, it has to download these. Maven is centralized, so Maven has to download every time. So when you're running your code, also another reason for using Ant in the classroom examples is I don't have to pull things from the central repository somewhere else in the world every single time I hit the run button. But we will look at Maven quite a bit. Gradle at least once. When we do our Spring Boot stuff and go to get those starter files, I was going to recommend getting them in Maven, but we can choose any option. I was getting ready to say we'll use Maven, but yeah, that's because that's what I used in the screenshots that I took. So we need to give it a name. Java application 1. That sounds like a good name. Here's where it's going to save it. Choose all that stuff. Create main class. We probably want this on Thursday's example. I'll uncheck the create main class and create a new one, but for now, we'll go ahead and create the main class. Anyway, There's some comments I'm gonna get rid of. Here's a Java doc comment. Let me type it in again. So like slash asterisk up to asterisk slash is a multi-line comment. There'll be line breaks between those. If we start with two asterisks, notice how we already added something like the author of this project. Or down here as at param, and that parameter for the method is already in there. Those are the ones we'll generate websites with, but for tonight, those are cluttered. So here's the automated, the to-do comments. I always show those in Python, so some of y'all may have seen them before, but if you haven't seen it's slash slash to-do in all uppercase letters. And to get to our to-do list, it's under window and let me check. Under all task. Oh, maybe it's not under task. Window, debugging, variable. Oh, not debugging, debugging. Oh, under IDE tools. Oh, which one is this under? Action items. Zoom button randomly after those. There it is. So if you have action items and then this third icon down that looks two orange boxes, there's that to do comment, which is a link back to this, which is already highlighted. So that's where the to do comments show up under action items. And so when you're putting your code together, just a single line comment with to do and all uppercase letters puts together your to-do list and their links, and that's part of the language, not any particular IDEs. So any IDE you choose to type Java code in should work with that. Let's do the same thing we just did. So system dot out dot print line, it goes on from there, right? In NetBeans, there's a shortcut S out, and before we do anything else, hit tab, and that gets our system dot out dot print line. So I'm gonna hit end, then hold shift and home to highlight that whole key. S out and tab get your system dot out dot print line very quickly. Pretty much any IDE that knows Java will do that, and so there's what we had earlier. No surprises there. One thing that's different is notice the package name. Hey, that's going to be important. We'll talk about that soon. Over here under project, actually, if I go to File Explorer, this is kind of the one thing that's different. Oops. Under NetBeans projects, here's Java application 1. And then in the source folder is Java application 1. That's the package name. So it essentially relates to the folder name. There's a couple other things we'll work in there later, but for now, starting out, the first line in your Java program should be the package, which is the name of the folder, because your class knows about everything else in the same package. As long as it's in the same package, and at that point, it doesn't necessarily have to be in the same folder. It could be in a different folder as long as they have the same name. If they're in the same package, they know about it. But for now, put everything in one folder, and put that package, folder name, and semicolon. I'm going to say end of instruction anytime we type those. I haven't used those before. Technically, that means next instruction. Back to how the computer reads our text file backwards. Semicolon technically means next instruction. Because of where we type it, I'm going to say end of instruction. Okay, so like system.out.println, blah, 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 end of instruction. So white space does not matter. White space is only for your own readability. We can do this in one line. Oops. Take that out, and then this white space out, and this white space out, and this white space out. You'll notice the compiler has no trouble with that at all, but it is kind of a mess. So the white space is only for your own readability. Um, I'm going to do the convention where the curly braces are there after the header, and then we indent everything inside and unindent the closing curly brace. And labels on the closing curly braces are useful in Java in class, in class. But kind of a messy name. And remember, the class name has to match the file name, so all of your IDEs know that. Which that's one of the things coming up in Java 21. This has to match the file name, so the compiler should be perfectly capable of typing that line. It has to be exactly that line based on the file name. So in Java 21, the compiler is going to start typing that line. Same thing, public static void. Our starting point has to be public static void. So the compiler can type that for us. Things that'll make it easier. We'll see that soon. Inputs are, let's see. Yeah, I think we'll look at inputs and stuff in a couple days. I'll have that on the notes, but I also wanted to look at preview the other way we would run things. So this is the console output. But like your final project is due in a web application, right? So, and by web application, I mean we're going to use HTML to make our input form. Java does not have a built-in GUI platform. Actually, Python is the only language that still has a built-in GUI platform. And they actually want to get rid of it, but they can't. They wanted to get rid of it for a long time because y'all have noticed that that built-in GUI platform was clearly built in 1987. And seems a little bit out of date. So they wanted to get rid of it for a long time. Java found a way to get rid of theirs in 2018. They got rid of theirs. And the standard is we use HTML and create what's called hybrid apps. We make, thinking of HTML, we make that web application. Then we use like the Electron framework to launch that same application as a desktop. And then there's other frameworks. There's not really one that stands out like Electron does for desktop, but a similar thing, a framework that will launch that to look, that web application to look like a mobile app. So we write our code once and just launch it on all of our different devices. That's what's called hybrid app. That's that SDEV 257 class that keeps not running. Well, has never been yet. So we're going to be looking at frameworks. But Java also has that built directly in with JSP. So I'm going to create a new project here. And this time I'm going to go choose the Java web one. And we're talking about this soon. This is just preview mode. So NetBeans has to find it. These are the two things we'll be using. When we get to the final project, when we'll be using, we'll generate our starter files with the other thing. So we'll be using the Spring framework. This is actually just part of the core Java language, what I'm getting ready to do right now. Not anything special. Bless you.
Thank you.
Web application one, that sounds like a good name for it. So this is preview mode. We will see this soon, and I know it's been a lot tonight, so if you just want to watch for a second. It's a web app, so it needs to run on a server because Java runs on the server and only the result gets transmitted to the client. So I have Jamf installed, so I need to add a server. I'm going to click add, and I'm going to Apache Tomcat server. Jamf included one of those. So I want to choose an Apache Tomcat server. Go next, where's it at? And on my computer, it's under PC, the C drive. There's a Jamf folder. And in here is a folder called Tomcat. I think we want to point at the bin folder. Oh, wait, no. We want to point at the folder where we can see bin. So we can see bin, all the binaries that represent it. don't actually click the bin folder, but go to the folder where you can see the bin folder, which is if you use the default installation of XAMPP, that's going to be on C drive, and yours it's under. I mean, if you're on a Mac, it's under Applications. We go to where the XAMPP stuff is, and inside of that, you'll see a folder for Tomcat, and it might be a couple layers deep, but somewhere in that Tomcat folder, you'll see the bin. So go to the folder where you can see the binaries folder, the bin. Open that, and then I'm just going to put a username and password. And this is NetBeans username and password in order to access that. So it will set up the user account and everything, does the checkbox, create user if not exist. So finish that. So now it knows where the server is. Next, we'll be using Spring Boot, the Spring framework later, but for now the core Java language has JSP pages in it. So there's a better way to start the framework stuff. So just don't skip checking any of those and finish it that way. Did they fix it? Awesome. Last time I installed NetBeans, it went back to an HTML template from like 12, 13 years ago. So you can see there's some HTML code here. I'm actually going to get rid of this in a second. And so we have a different thing. This just says index.html. I'm going to replace that with index.jsp. So I'm going to close that. And at the same level here, so these are default names for folders. We can rename them, but it's probably easiest to stick with the default ones. I'm going to hit a new file. Right click and a new file. And I want a JSP file, which NetBeans remembers I've done that recently. If you don't see it, you can go down to Other and here's all the types of files NetBeans knows about. See lots and lots of folders. Under Web is JSP. I'm going to call it index, and it'll add .jsp extension. If that looks like a good location for it. Make sure it's a JSP file, not a JSF or a JSP segment. We'll just be looking at JSP files, but the other ones are similar. JSP segment is we just do little pieces of it, so we can put the pieces together in different combinations. And JSF is an over format we don't need. We get that comment out of the way, but now you see there's some HTML code. I'm going to get rid of this thing that says hello world. And I'm going to come up here, maybe anywhere remote, but I'm going to push angle bracket and %. So kind of like a tag, and then come down and do % angle bracket. So I have this other tag here that you'll notice NetBeans already changed the color on, like it knows what's going on with it. And I'll just set up some code here. So I have some string type data. We're in preview mode tonight. I know it's already been a while, so just want to follow along for the preview. This is the other thing we'll be doing. We didn't do a strictly type thing. We always have to say what type of data we have. We can't just throw out the string there. We have to tell the computer, put enough space in memory to create a string. I'm going to call it message and set that equal to, I could just put it here. I'm going to use this format. This is what it's going to look like most often. String type of data, the name or reference name, the variable if you want to call it that. The variable is very, very vague. There's lots of things that are variables, right? A method is a variable. Method is a variable holding instructions instead of data. The variable is that catch-all class. So this is usually our data reference would be the technical term for it. And that equals something new, a new sort of string, end of instruction. And this is what it usually looks like. Data type, reference, is assigned a new instantiate object constructor. So we'll talk about constructors and stuff soon. We're going to use this constructor, and I will put the string here. There's a more abbreviated way to do strings. This actually creates 3 strings, what I just did here. Oh, wait, I'm on a JSP page. I actually just created 4 strings in RAM. So there are much more efficient ways to do it than that, but this matches our general syntax. Data type, reference value, assignment, a new object constructor. We will see what all of those mean soon. So I just say that's Java code. I'll come up over this other one. That's kind of like, instead of printing that out with string data, I'm going to call it message. That's going to be a new string. It's equal to hello world. And then instead of typing that directly here, I'll put what's in that message variable. I know that went quick, but did everybody follow what I did there? I did want to do something quick this evening because this is your all's 3rd programming class. That change makes sense. And see how I have that same thing here. That goes, I'll run it and you see it still works the same. I almost kept hitting the wrong button. I might do that sometimes, just speed, but this has to be at least your 3rd programming class. We can do it a little bit faster, right? So I have that line, set that up, and I'm coming down here and under this H1 tag, I'm going to have a special tag here again, angle bracket %. This time I'm going to put equals. And now I'm going to ask for that variable name and then end that tag. So it's kind of like a tag, but notice what goes in there is the variable I created up here. So the server is going to run this Java code, and then this just gives us a place, and then we can put the results right in our HTML. And that's how we make forms and stuff, make things look really nice, because CSS, we have lots of control. Now I'm going to close that previous output, hit run button again. I always like to make sure that the right thing is here. There's 2 things called index. So I'm going to delete the index.html. Don't need that. We just need the index.jsp page. That way it doesn't get confused on which index it's supposed to show. We run that, got to give it permission. And I don't know why have y'all noticed the default anymore is to not run on a private network? But that's the one that would be safe. So if you haven't seen that yet whenever you give it permission, make sure you tell it it's okay on your home network. You'll probably want that, otherwise it'll ask that every time as you're doing your homework. But they changed that default so that it doesn't automatically run on your home network. I can see why it's not safe at times, but we're accessing a virtual server on our computer, so it's not going across the network. But once we allow access again, and now notice the authentication. So this is that Tomcat user we set up. So create a Tomcat user with the username Chris, and I did the weakest possible password. Y'all can't tell what it is from the 5. Actually, the password is 5 letters. Same length as the username. Oh, I need to change that because I certainly don't want to use Edge. But localhost port 8080. If you haven't seen that before, colon means port number. So we have our IP address, which is actually 127.0.1, right numbers. Colon means port number. How are we accessing the server? So we're accessing on port number 8080. That's just an agreement between client and server, an arbitrary number they agreed on, that as long as both of them agreed to that number, say they're on the same number, then that's sort of a confirmation. And we're accessing on the server, and there's that message. Because over here in our code, you see there's nothing else. Hello world only appeared in the Java code. So that's how we get the results of Java on there. Real quick, might as well point at this because that opened an edge because I just did a factory reset under tools. There's lots of options here. So what colors? Did you figure out how to change the colors, Jenna? She went and changed the running a Zoom call and she changed it to dark, but it only changed the text editor to dark. And the stuff wrapped around it was still white. Um, so lots of control over that. There's templates, so if you want to change the template, like maybe you like the curly braces to start on this opening curly brace on the next line, you can just change that in your template. Change what the default things are. There's lots of options. Um, Browser val. So I want to switch to a different browser. So I want to definitely want to use Chrome. So under the HTML, JSS, you choose which browser it opens with, which is in program files, in Google, Chrome, application. So there's where it says what browser it opens with, which I might have to actually restart NetBeans to see what opens Chrome this time. I think it's still Edge. I think I have to restart NetBeans. Oh wait, maybe it's someplace different. Under Java, GUI Builder. I might have to look at that. I mostly just wanted to point where those were. Well, GUI terminal. Oh, web browser. So under general, to see the default web browser, which mine should be Chrome. Switch to that, or you might when you use Firefox. A lot of people like Firefox. There we go. Now it's in Chrome. So we have control over what browser and everything. You see that same address. Uh, I really like to write the Java code there instead of the main method because I was around and using computers when GUIs first kind of came out. Well, when Xerox was working on the invention, I was alive. I was a baby then. But by the time they got popular, I remember when Windows 3 came out. And I was so happy that I would never have to use a console again. That wasn't quite the case, but anytime there's nice graphics, I'm happy about it. So those are the two that we'll be using. That's a Java server page. It's also Java servlet, and they're part of the core language. We didn't have to import anything. We didn't do anything special to get that HTML integrated into Java. So you can make your output look really, really nice that way, or use the main method to spit it out on the thing. We'll be looking at those two things this semester. We'll also be using the Spring Boot framework, which takes that server-side stuff a step further, and the default one is 3 lines of code and your data set away from having a REST API. So super quick to just get your API data transmit across the internet. We will see that soon. A lot of things easy, but we'll do a lot of this stuff, kind of mix and match them. And your final project, the HTML is just for the input form. That's what you do for a GUI. I put in the instructions 2 pages, right? One for the input, one for the output. Maybe the easiest way to do it. We can also make it all fit on 1 page, right? You have the input form elements, and then you just spit it out to another element with a couple lines below it or something. You want to do it on 1 page, but your final project, the GUI will need to be on a JSP page like this. Because consoles are boring. Everybody wants to write their own code. And with HTML, we have CSS, which makes it really easy. And in NetBeans, if you're doing HTML, has everybody seen HTML? Okay. More than happy you all have me for an HTML class. But in NetBeans, if you go to Window and Palette, where is Palette? Probably under IDE tools is Palette. And here's your drag and drop for HTML. So if you want an ordered list, you just drag it from over there. Do 4 items in our ordered list with the disk. I mean, okay, and then there's that. Probably could drag it down to the next line. But you see, just drag to type the HTML code. Which for inputs, there's all the forms. The second option down, so your input forms, and then some tables for the output or something. and then Java code intermingled with that to do the processing. And it does all run on the server. And that again, it should. Let me close these previous running ones because I don't know why it didn't just automatically open the page. Oh, there it goes. Just going really slow. So if you page source, you'll notice that we know the Java code runs on the server and the client only receives the results of it. Hopefully no surprises there. I like the JSP pages. I'm also excited because my very first semester teaching, the first class I taught was Java class. I came in there and looked at the list of major course learning objectives. So one of the things on there, the applets. And this was in fall of 2018. Applets had been deprecated for a couple years at that point. And this was August of 2018. And in January of 2019, browsers were removing support. So they wouldn't even work anymore. So my very first class that I taught, starting in 2018, there was outdated technology on the major learning objectives. And last fall is when I became the vice chair of the software development committee and finally got that off the paperwork. So it took me 5 years to get JSPs on the pages on the paperwork instead of something that was deprecated and blocked from even being all the browsers blocked it for like the last 5 years. Academia moves slow. So maybe it's just that I'm excited that I finally got that paperwork changed to some existing technology. Java server pages existed before applets, but applets were based on like Flash technology, if y'all remember Flash. It was necessary at one point. It was necessary with slower bandwidth, but it was no longer necessary and it is highly insecure. So we weren't dealing with, nobody wanted to deal with the security risk when it was no longer necessary to circumvent slow bandwidth. So JSP pages, Java pages, we will see input, more examples coming up soon. 1 minute from what I want to finish. Anything else putting on the list? Window policies. So our first example, preview mode tonight. We will talk about this in detail. Java is a compiled, strictly typed language. We saw the compiler. We always have to say what type of data we have. We reserve spots in RAM. We can't just let me stop screen share. So back to the stack heap diagram. Going to use these pictures a lot. We can't just say we have a variable, it's pointing at some spot in RAM. That's not enough. In our case, that first example, we said we had string data. So now that's more explicit that we need, that's saying, telling the computer we need 64 bytes in RAM. So now, unlike those dynamically typed languages, the computer never has to take time to figure out how much RAM we need. It goes over there and blocks off 64 bytes. So like, here's 64 bytes. And it's a lot quicker because we do know how that, right? We know how much that's going to take. So, and it takes the computer a long time to figure out what type of data it has because it has to look what happened before, as much as it can, try to preview what's happening afterwards and estimate it. In Python, if we would say, okay, we need a variable, it just gives us 64 kilobytes. But if our string fits in 64 bytes, that's just wasteful. There's a lot of other things that could be happening on the rest of those kilobytes in RAM chip, just because Python doesn't know what type of data we're going to put there, so it has to reserve a lot. So strictly typed stuff, we will see a lot of that, and it's a great example of the fine-grained control and that we control how fast our software runs. We look at those strings, right? We have more than just say print. We tell it how to print. We want to print it to the console 4 bits at a time, or print it to the console 64 bytes at a time, and buffer the buffer. Y'all know what buffered streams are, right? Well, when you're watching YouTube and there's that gray bar ahead of the red bar where you're actually watching, it's in chunks at a time. We'll see a lot of that stuff, fine grain control, and then we'll get into data structures, which often confuse people at first. So we'll introduce them, and then at some point in the future, after you've used them a few times, it'll start to make sense. So at the end of the semester, there's gonna be a couple things that are confusing. And you're gonna be like, "What? That doesn't make sense." Everybody feels that way. This is the course where we introduce them, and then you will have a much better understanding when in on this sentence. Those things that are going to confuse you, once we see them, you'll have a better understanding on why all those job requirements want 5 years experience. Because right now, just all the introductory Python and everything you wrote worked. It's like, okay, this makes sense. Why do they want me to do this for 5 years? We'll get into the advanced stuff. So by the end of this course, you'll have a much better idea of why people are asking about that. And a couple things, like when we look at the code for a heat, very confusing. Take a while to think about it, how to use it, all that stuff, but much higher level of programming than what you would have seen before. Hopefully it's going to be a really fun class too. Does anybody have any questions? Oh, I have one other note, which will go really quickly. If you use chatbots to write stuff, we don't have many writing assignments. There are going to be two discussion boards. I haven't added them yet. Some of y'all have seen them before. I'm going to do the one where you're required to use ChatGPT, and then really what you're discussing is tips and tricks for getting optimal results with that with your classmates. Required to use a chatbot, and then there's going to be one where you make it. That one goes really well. Is taking something from a language course, right? If you get the humor in the other language, then you know you understand it. So at some point near the end of the semester, you're going to be required to find a funny picture and make a meme about Java. That makes a great discussion board. I thought it went over really well last time. But Joseph put out some great memes that time. There were some good ones in that. So I like that. So we'll have those. But for writing assignments, if you do use chatbots, please use different ones. That way you're learning how to use the tool, not one particular one, because ChatGPT is seriously out of date. But people know about it, so they're still promoting it heavily. So you don't want to learn to only use the one that's out of date. So if you use that for the writing assignments in this class, please use a different one every time. That way you're learning the general tool usage. I did have all on the notes. Okay, that'll be it for this evening. We'll jump up there, and this, in general, the class is going to be a lot like that last time where we worked through an example and then jump over, draw pictures on the board, look at different things, talk about what all the keywords mean. It's an active subject we learn by doing. So if you want to start working through some examples, we'll do that. But the examples I have planned for Thursday are going to address most of what's in the homework this week. So otherwise, if you have any questions, let me know. I'll see you on Thursday. Have a good one. Oh, and if you have any questions, I'm just going to be sitting around waiting for your questions until 9:50. But you don't have to necessarily hang out here. See you Thursday.